Hi everyone, good evening. And today our group will be presenting on a reduction reaction. My name is Liew.
My name is Chia Qiu Xia.
And my name is Suryasri Ragavan.
Okay, so redox reaction is a type of chemical reaction that involves a transfer of electron between two species. There are two types of reaction, which include oxidation reaction and reduction reaction. Reduction reaction is a type of process which involves the addition of hydrogen or any electropositive element or the removal of oxygen or any electronegative elements. While reduction reaction is a process in which an atom or ion gains one or more electrons. So here are a list of reduction agents, which are hydrogen, sodium borohydride, lithium aluminium hydride, alkyl metal, formic acid, and oxalic acid. There are a few types of reduction agent. Now we'll be discussing the hydrogen gas, metal hydrides, and dissolving metals. In hydrogen gas, there's a reaction called catalytic hydrogenation. Its component is the two hydrogen atoms, two electrons and two protons, and also a hydride ion and a proton. While the catalyst is platinum, palladium, and also Linda's catalytic that is only used to alkyne to cis alkene. Here's some examples. Like the alkane will transform into alkane, and also alkyl transform into a cis alkene, and also an alkyl chloride transform into a primary alcohol. Next slide. Here's the mechanism. In the first step, adsorption of alkene on the surface metal, and the second step is adsorption of hydrogen on the metal surface and is reduced to a form of metal hydride. The third step is the formation of first CH bond. In this step, CH bond is formed with the breakage of CC bond, resulting in direct C metal bond. And the last step is the formation of second CH bond. The CH bond is formed resulting in an alkane, which does not bind strongly to the metal. Now I proceed to the next presenter.
So just now, my group member already present the reduction reaction by using the hydrogen. So the second reduction reaction is by using the metal hydrides. So this is called it as addition of hydride ion and a proton. So the reducing agent that we will use is lithium aluminium hydride and also sodium borohydride. So actually the lithium aluminium hydride is more reactive than the sodium borohydride is because the product that it will produce is more than the sodium borohydride. So this is the example of this reduction reaction. So the carboxylic acid will be reduced to primary alcohol. The amide can be reduced to amine. The aldehyde will reduce to primary alcohol, and also ketone will reduce to secondary alcohol. So this is the mechanism by using the lithium aluminium hydride. So the first step is deprotonation. So the aluminium hydride negative charge will break down the oxygen and hydrogen bond, and the second step is addition of hydride, and it will break down the carbon oxygen pi bond and form the carbon hydrogen bond. And the third step is elimination. It will form the carbon oxygen pi bond and break the carbon oxygen bond. So the product will form is aldehyde. So it will further doing the reduction reaction to produce the alcohol by addition of hydride and also protonation, which is addition of hydrogen ion. So the second mechanism is by using the sodium borohydride. So here got two steps. So the reagent it will use is aldehyde. So it will break down the carbon oxygen pi bond and form the carbon hydrogen bond. And the protonation is form the oxygen hydrogen bond by add on the hydrogen ion to form that primary alcohol. So the third reduction reaction is by using the dissolving method. So this reaction is called it as alkynes to transalkenes. So the reagent it will use is sodium methane in ammonia or also the lithium methane in ammonia. So this is a general equation for this reaction. So this is the example 12 from the alkyne to the transalkene. So for the mechanism, it has four steps. So for the first step is addition of electron to alkyne breaks a carbon-carbon pi bond and produce a radical anion. And also the second step is protonation of anion by ammonium. So it will form the carbon-hydrogen bond and break it down the nitrogen-hydrogen bond from the ammonium. And it will produce the vinyl radical. So for the third step is reduction of vinyl radical and it will give a vinyl anion. So for the final step is protonation. It will produce a transalkene.
Alright, so next I'll be explaining the reduction of different types of compounds with examples. So I'm going to be explaining 4 examples, and the first one will be mechanism of reduction from alkene to alkene. So the mechanism would be the alkene first absorbs onto the metal catalyst surface, and then the hydrogen molecules will dissociate into atoms on the catalyst surface, and then the hydrogen atoms will transfer to the carbon atoms of the double bond. And finally, the product alkane will dissolve from less electronegativity catalyst surface. And the second mechanism would be reduction of amide to amine. So for this, lithium aluminium hydride will donate a hydride ion to the carbonyl carbon of the amide, forming a tetrahedral intermediate. And this intermediate will collapse, ejecting the leaving group. And further, the hydride addition will reduce the intermediate to an amine. And the next mechanism that I'll be explaining is reduction of carboxylic acid to primary alcohol. So in this, the carboxylate oxygen is protonated, making it more electrophilic, and the lithium aluminium hydride will provide a hydride ion to attack the carbonyl carbon, forming a tetrahedral intermediate. And then the intermediate will collapse, which will reduce the carboxyl group to aldehyde, and the further hydride addition will reduce the aldehyde to primary alcohol. And finally, I'll be explaining the mechanism of reduction of ketone to alcohol, secondary alcohol to be specific. In this, the hydride ion from the reducing agent will attack the electrophilic carbonyl carbon of the ketone, and then this will form a tetrahedral alkoxide intermediate, and this intermediate will then be protonated, usually doing a workup phase with water or an alcohol, resulting in secondary alcohol.
In conclusion, our slide has included the definition of reduction reaction, the types of reducing agent, catalyst, hydrogenation, addition of hydride ion and proton, reduction of alkene, amide, ketone, and carboxylic acid. That's all from us. Thank you.
Thank you.
Thank you.